Linalool spot is a little bit too big, in fact, but it's not very UV active. And the 2-phenylethanol seems to be more UV active than the phenylacetate. So I've got my 6 standards, and I'm going to use 2 of these 1 to 9 jars to put these plates in. And then while these are developing, I can spot a couple more plates with the same standards to put in the 2 to 8. So I want to try to make sure that when I put that in there, it doesn't touch the sides, because if the solvent wicks up the side, it'll then develop sideways as well as up the plate, and we'll get our plates moving and maybe even falling off the edge of the plate. So I'm going to stick that in there. Being careful not to touch the sides, and then put the cap on and let those develop. So I'm kind of keep an eye on those and grab a couple more plates. Making sure only to touch the back and the edges. So again, we mark our X's. Helps if I use the silica side, since the plastic won't absorb compounds and can't be written on. And again, we've got our linalool, our phenethyl alcohol, phenylethanol, and our phenethyl acetate. And over here we've got our guaiacol, our eugenol, and our vanillin. If you can develop the skill of uncapping and recapping a vial with one hand, it does make your life a little easier. You see that when I spot that, I'm tapping it and then letting it evaporate a little bit and then tapping it again so that my spot doesn't get too wide. And I'm going to start just throwing these on the floor. It'll be swept up next time they sweep in here, rather than walking over to the glass waste every time. If you dip it in there and leave it in there for too long, you may find that your compound goes all the way up the capillary, in which case you're not going to be able to break off and reuse. This lab has actually never been done before, so I don't have a preconceived notion of exactly what things ought to look like. Or kind of about what to expect from the RF. So I'm spotting a little more heavily than I would normally spot, just to make sure I have enough compound to really see it. So there's a good plate ready for the 2 to 8 mixture. I think you probably noticed that the 3 compounds that have the phenol, the guaiacol, the eugenol, and the vanillin, that have that OH group attached to the benzene ring, are definitely more UV active because of that extra lone pair participating in the pi system. The longer the pi system, generally the more UV active the compound. I'm definitely getting to the point where this capillary is a little bit too thick to get good spots. The thinner the capillary, the finer the control you have over the size of the spot. And that's not going to be useful anymore. I'll throw that away. So I've got 2 new plates ready, and I can put those into the 2 to 8 mixture, by which time hopefully these plates are pretty close to having been developed. Again, trying to make sure I get them centered. You could use tweezers, but I find that I'm clumsy with tweezers, so it's easier to just work with my hand and be careful not to touch a big fingerprint. So I'm watching the solvent go up the plate. I can open up the jar and you can see that it's mostly to the top. I'm going to quickly mark the solvent front. That's how far the solvent moved, because I'll need that for calculating my ratio to the front. And this one, right, I already had that line and it's moved right about up to that line, so that's perfect. So those are done in the 1 to 9 mixture. And I've got my 2 to 8s developing nicely. I'm just going to let the solvent fully evaporate, wave them around a little bit. It's not such a great idea to move jars once they've already started developing. I did it fairly quickly. Hopefully didn't do any damage. So now let's see what these look like. So we can see that the vanillin basically didn't move in the 1 to 9. I'm going to circle that. That's close to an RF of 0. And then the eugenol and the guaiacol moved a very similar amount. So we're not probably going to be able to tell the difference between these two in that solvent mixture with those RF values. Over here, the phenethyl acetate moved quite a long way. The phenethyl alcohol, because it has that OH group, didn't move very far, and the linalool is invisible, since that one doesn't show up in UV at all. This is a great solvent for the 2-phenethyl acetate, because we've got that spot moving close to the middle of the plate, which would make it really easy to tell whether there's something on either side of it. It's not a great solvent for the 2-phenylethanol because it's not really moving far enough, so if we had a low RF spot, it's not going to separate. But this is definitely a great solvent mixture for separating 2-phenethyl acetate and 2-phenylethanol. We don't know where the linalool is yet. This one's a good mixture for separating vanillin from either of the other two, the guaiacol or the eugenol. Eugenol has that extra allyl group on it, so it's got an extra pi bond and an extra hydrocarbon fragment. So they should actually move a little bit differently if we can get the solvent mixture right. This is a decent solvent mixture for that. That RF is somewhere between, somewhere around 0.2 to 0.25 probably. But not great. We'd like to move them a little further. The 2 to 8 mixture is probably going to be a better mixture for this separation. So the next step on these, now that we've circled the spots so we know where they are under UV, is to stain them and see what they look like when we put them in an iodine chamber or use phospholipid acid stain. And those are developing nicely. I don't know if you can see the things are up to about there. Move that, let that move a little further, and I'll go get an iodine chamber. The iodine visualizing jar is simply solid iodine suspended in sand. And that's to decrease the evaporation rate. So if you look inside there, you'll see that there are some iodine crystals inside the sand. So to develop a plate in an iodine chamber, you just kind of stick it in there. I can do both at the same time. And then the goal is to shake this around so that the plate is completely covered by the iodine in the sand. Right? And what will happen if the iodine reacts with your compound, which it usually does if you've got a double bond in there. I'm going to grab some tweezers. because I'll need those when I take it out, is you'll see dark brown spots on a kind of maybe a pale brown background. So that's moved up nicely. Mark our solvent front. Let that dry. Again, mark our solvent front. And we want to let those dry, and then we'll look at them under the UV light. You really can't let it go too long in the iodine chamber because the iodine will sublime off. So if it gets too dark, you just let it sit for a while until the iodine sublimes off, and then you will have the correct level of development. So I'm going to go ahead and just leave that in there while I have a look at these plates under the UV light. So our vanillin has moved, not a really long way, but at least it moved off the baseline. But our guaiacol and our eugenol, again, look like they've got very similar RFs. It looks like if we went a little bit more polar, the eugenol is starting to move maybe a little further than the guaiacol, we might be able to get those to separate. In the 2 to 8 mixture, the 2-phenethyl acetate has moved a fair bit. The 2-phenylethanol has moved a little further than it did in the other one. It's starting to be a better solvent mixture for that. We could still afford to increase the polarity a little bit and move the phenethyl acetate further up. Definitely for this one we could afford to increase the polarity a little bit more. And the linalool still invisible. So what you're going to do is you're going to using the pictures that I will upload of these, go on your computer screen and you're going to measure the distance from the starting line to the center of the spot or the front of the spot. You can choose whether you use the center or the front of the spot. And then you're going to measure the distance all the way to the solvent front, and you're going to take that ratio and record those RF values in a table. That should have been sitting in there long enough. Oops. Apparently I didn't tilt it quite enough before I took the cap off. So we'll pull these guys out and see what we see. I'm going to stain this set of plates using a different stain. And for that stain I'm going to need a hot plate, because that one needs to be heated. So while we're waiting for other things, I'm going to plug a hot plate in. These hot plates don't have a control on them, so these are the ones that plug in down here. And we use, we turn this on and use a setting of probably about 60 on the dial. That's 60% of the line voltage is going to the plate. So I'm going to set that aside and let that heat up while we're waiting. So you can see that all three of the spots here, the vanillin, the eugenol, and the guaiacol, all stained nicely. The guaiacol stained very dark. The other two stained a little less dark. And you can see that the linalool, because it has 2 pi bonds in it, does stain. Since that's going to fade, I'm going to go ahead and circle that with a dotted line to indicate that it wasn't UV active, but it did stain with the iodine. And these other two compounds, the 2-phenylethanol and the phenethyl acetate, really didn't stain much at all. I need a paper towel. The other stain we're going to use is a solution of phosphomolyptic acid in ethanol, 12 weight % phosphomolyptic acid in ethanol. And that's what this green stain is here, because someone didn't use a piece of paper towel, and since the phosphomolyptic acid isn't soluble in water, you can't wipe it up. You can see that there's also stain on the hot plate from previous use of that phosphomolyptic acid stain. The phosphomolyptic acid stain, when you're not using it, lives in the refrigerator on the top shelf of the door. grab one of these, being careful because someone has spilled all over the outside edge of the jar. And that's kind of nasty. So I'm actually going to get some ethanol. And some gloves. And a couple of Kim wipes. And I'm going to wipe the outside of the jar. Clean that up a little bit so that we don't have to get phosphoric acid all over ourselves whenever we touch that jar. You can see it's quite soluble in ethanol, even though it's not soluble at all in water. Not a bad idea to use gloves when you're working with a phosphoric acid stain. While I'm at it, I can wipe up the stain on the bench. And that can go in the solid waste container. Still not as clean as it might be, but a whole lot better than it was.